Okay. Hello. This is Dr. Ma, and this is an introduction on the two type of sequences, arithmetic and the geometric sequences. Okay. Arithmetics. The word arithmetic means to add or subtract. Okay. Here's examples. If I'm walking down a block and looking at a house number 1, 3, 5, 7, etc., and I ask you, oh, describe what you see. And you say, oh, I see the patterns. And what is the patterns? Well, when we describe it, we say, well, it starts with 1. No, we know there are numbers, but to describe specifically, we say it starts with the number 1, then keep adding 2 to get to the next number. So this is the pattern. Okay. And versus what? Versus the other type. Geometric. Okay. And these are different type of patterns of numbers. And where do they come from? Why the word geometric? Or geometric means to multiply here. So when we hear the word geometric progressions, it means multiply progressions or multiple factors. And it starts from here. That's where the word geometric, this is where the word geometric came from. If I measure the length of something, it's a number, okay? Take this and rope it around, make it into a square, and it covers a certain amount of area. And to get the number of area, I multiply the length times width, or 2 times 2. Okay. If I take this piece of area, I make a box out of it. Take 6 of them, glue them, and then glue the edge together, and I get a box and ask, say, hey, how much does this box hold? How much water it holds? How much can I pack inside it? Well, the answer is going to be 2 times 2 times 2 again. It's going to be 8. And that's what the word geometric. It means it came from measuring in geometry, measurements in geometry. Okay, so they produce this type of numbers. What are we going to do with it? These geometric and arithmetic sequences. And here's what we're going to do. We're going to we're going to come out compute the particular formula for particular sequence. For instance, for arithmetic sequence, we will be given a particular numbers 2, 5, 8 particular sequence. Then the question is to find out the formula describing this arithmetic sequence. Okay, to get to that formulas, we first have a general formula that we going to fill in the blank to get to the particular one we have. Okay. And because of arithmetics, adding, subtracting, and so this is what the general formula down here looks like. And if we go up back to geometrics, the formula, we're going to do the same thing, except the formula looks different because each step we're multiplying by a number r. R is the number we multiply each time. So the formulas stack together, except adding, subtracting is multiplying r times r times r. So it become a formula, exponential formula. Okay, so that's what's happening in geometric sequence. And here's the example, go back to arithmetics. Now we use this type of formula. And so this type of example we're going to have. Here's a sequence. Okay, we'll find out what the difference is between the numbers, which is 3. Okay, and we'll find out what the first number in line is, which is 2, and then stick the 2 into the first number position, 3 into the D, and then voila, that's it. And that's the formula for the sequence. Okay, same thing for geometric. Okay, here is, it says first check is geometric. That is, you multiplying a number, a fixed number. In this case, actually, it's -3/2. Okay, and so you do a little checking. Okay, and then I can put in the specific formula. You know, here is the general formula. Put down the A1. A1 is 2/3. The first number A1, put it over here, and putting what I is minus 3/2. So put over R, and that's it. Okay. So it's very easy to get the specific formula. Okay. And what is good for? Well, I can use this specific formula, say, for instance, in these arithmetic ones, back to arithmetics, what's the thousandth number down the line? And all I have to do is plug in the thousands into these formulas and I get the answer. That's why we need this formula for. Okay. And you have a similar examples that's for the geometric that I will not go on, okay, go into. And then what? Well, then from here on, we make the problem a little bit more complicated. That is, we begin to hide the information. You know, in this particular example, I don't tell you what the first number is, but I will tell you what the sixth down the line is 5. Then I ask you, say, what this sequence look like, if you like, what's the formula for specific formula for this sequence. Basically, you have to go back to find the A1 because the general formula needs that A1. You find the A1 first, and unfortunately D is over here is known, so all you have to do is then just plug the D in A1, and then you get it. And this is the calculation one through that. Okay, then here's example where even the D is not given, so you have to recover both A1 and D. And this is the calculation you go through to recover the A1 and D for arithmetic. Okay, and similarly, it has similar type in geometric, similar type of problems in geometrics. Just to show you the difference between the algebra. Okay, here again, it's geometric. So ask you to find the first number so you can go back to find the specific formula. And here's how you recover the first number. Okay. The algebra is different because they're all dividing or multiplying. The other ones all add and subtracts. And then you can plug in to find a specific formula for this geometric. Okay. And then we, just like the other problems, we begin to hide the information. You have to find the R for the, and A1 for the geometric sequence, then get the specific formula. Okay, so that's the name of the game. And the algebra are fixed. You say, what do you mean fixed? It's always the same procedure you have to do. Okay, and so I'll leave it to you to do that. Then what else will we do? Let's go to arithmetic. So now back to arithmetics. Okay, the add and subtract one. Okay, it's easier to start out with with these type of situations. Next, we're going to add them. Here's how to add arithmetic sequence. Like here's 4, 7, 10. You have arithmetic sequence and all the way go on to 67. Okay, then I'm going to ask you to add them together. Okay, and in order to add them, you need the formula on top. You need to know how many numbers are here. Okay, that's where this n22 equal to 22. Why you have to find this number first. Okay, and then you can use the formula. Then you get a sum. Okay. And then here's an example for using the sum to calculate how many bricks you need to do, certain jobs, etc. Okay, and here's the geometric formulas for adding them. And this is important. Okay, here's adding, here's the sequence geometric 1, r squared, r cubed, r4, up to r to the n minus 1. These formulas, okay, add together equal to a simpler fraction ones. Okay, this formula is extremely important because this is what modern accounting is based on. So, for instance, if you have any kind of, if you borrow money, you have any kind of installment payments, okay, and the calculation of the interest is based on this particular formula. Here's examples on then how to sum. You know, here's this is a geometric sequence, and then basically you want to match this sequence. Basically, you want to view it like this. Okay, then match what's the first number, what's the R, and then you dump it into the formula right there, and to get the answers. Okay, and that's what the algebra down below is all how to accomplish that. Okay. So basically, these introductions on these two sequences. Okay. And the takeaway is you got two sets of algebra, and all the algebra steps for arithmetic sequence versus the algebra for geometric sequences. And the steps are fixed. Okay. I mean, all you do every time for different problems is you just putting different numbers and do the same steps. There's no variations. That's why it's so nice about some of these problems. Okay. Bye-bye.